Hey guys, Mr. Barnes here again, bringing another math video. Awesome math video, I should say. So this video is going to be a little short video on the distance formula. So those of you who are probably doing some geometry right now, have probably seen this, and it's a really important formula for coordinate proofs and things like that. So the distance formula basically is the square root of x1 minus x2 squared plus y1 minus y2 squared. So it looks very similar to the quadratic formula, to Pythagorean theorem, because essentially that's where this formula is derived from. So basically how it works is if you're given 2 points, so I'll just make 2 points up. Let's say 5, 2, and 4, 1, let's say, 4, 1. Then what we can do is we can find the distance between those 2 points, so the literal distance. So all we do, we'll label this one x1, y1. Doesn't matter which one we call x1 or y1, it makes no difference as long as we're consistent. And really, it doesn't even matter if we get them in the right order because we got the squareds here, so we're going to end up with positives anyway. But anyway, so square root of 5 subtract 4 squared plus 2 subtract 1 squared. So I end up with 1 squared, which is 1. And then, so 5 subtract 4 is 1, and then squared is still 1. 2 subtract 1 is 1, squared is 1, so plus 1. And I end up with root 2. So the distance between these 2 points is root 2. So if that makes sense to you. Alright, let's try another one. So maybe we'll get a little bit, go outside the box. Let's go some negatives. So negative 5 and 1 and 2 and negative 3. Alright, so let's call this one x1, y1, x2, y2. So then I'm left with square root of, so it's x1 negative 5 subtract 2 squared plus 1 subtract negative 3 squared. So you got to really be careful with that second bracket. Subtracting negatives and things like that, you got to be really careful. So negative 5 subtract 2 is 7, so 7 squared is 49. Plus negative 1 subtract negative 3 is 4. Squared is 16. So that's going to be 49 plus 16, so that's what? 59, 65. So now, most teachers are going to want you to reduce this root, so I don't know if there's any perfect squares inside of 65, so let's just try a few. Let's see. So 25 is obviously not going to work. 36, probably not. 9, probably be our only bit. No. So I don't think this guy reduces down. Correct me if I'm wrong. I don't think it does. But you might want to watch one of my videos on reducing square roots, because if you have to do that, you'll need to break one of those guys down. So a good example of that, if you ended up with something like root 50, and root 50 is the same as 25, which is a perfect square, so times 2. So that's what I was looking for, 65. See if any perfect squares divided into it so we can make a multiplication statement like that. So I know the square root of 25 is 5, and since 2 is just it's not a perfect square, we just leave it like that. So 5 times root 2, or 5 root 2. So you might have to do something like that with 65 if it had a perfect square inside of it. So guys, I hope this video helped. A little intro video to the distance formula. Use it in your coordinate proofs, and I'll see you guys in class. Thanks for watching.